This is a video for AQA Further Pure Mathematics. This is section 1.2 of matrices, where we're looking at how we combine matrices by multiplication. When we're talking about multiplying two matrices together, what we have to do is to take the elements in the rows of the first matrix and multiply them by corresponding elements in the columns of the second matrix and then find the sum. Now, as an example of that, let's take these two matrices, and first of all let's look at the first row in the first matrix multiplied by the first column in the second matrix. So what happens here is we first of all multiply by the 1 by the 2 and then multiply the 4 by the 2 at the bottom. So we've taken the first element in the row multiplied by the first element in the column, the second element in the row multiplied by the second element in the column. So we get 1 times 2 and then 4 multiplied by 2, and we add those two together. And that goes in the answer matrix, or the product matrix, in the first row, first column. So you can see that's the corresponding row and column that we've used in the two matrices that we're multiplying together. Now we repeat that for the first row and the second column. So when we look at the first row, second column, you can see that we'll get 1 multiplied by 1 and 4 multiplied by 3. Then moving down to the second row, in turn we combine that with the first and then the second column of the second matrix. So looking at the first column multiplied by the second row, we get negative 2 times 2 and 1 multiplied by 2. And then finally, second row of the first matrix multiplied by the second column gives us negative 2 multiplied by 1 and 1 multiplied by 3. Now, of course, we then calculate those sums and enter them into the appropriate place in the answer matrix. Now, in practice, that can be done without this intermediate line written in. You don't have to write out your working. You can simply look at the two matrices, combine them together using elemental arithmetic, and writing in the sum at the end. When doing matrix multiplication, the first thing that you should ask yourself is, what size matrix do we get when we multiply the two together? And you can see that here we've got two rows in the first matrix and two columns in the second matrix. The rows of the first matrix have got 3 elements, and the columns in the second matrix have got 3 elements. So we can combine them together. But because we've got 2 rows and 2 columns, then our answer matrix is going to have 2 rows with 2 columns. So it's worth drawing a matrix ready for your answer to go into. You can then do the multiplication, so taking the first row and the first column, we'll get 2 plus 3 times 2 is 6, so that's 2 plus 6 is 8, and then minus 4, giving us a total of plus 4, etc., to work out the other elements. So those first two matrices, the first one was a 2 by 3 matrix and the second one was a 3 by 2 matrix. The fact that we've got the 3's there in the middle said that yes, we've got the correct number of elements in the rows of the first matrix and the column of the second matrix. And then you can see that we ended up with a 2 by 2, which is the outer two numbers. Now let's think about this second pair. Here you can see this first one is a 1 by 3 matrix, and the second one is a 2 by 2 matrix. But those two numbers in the middle tell us we've got 3 elements in the first matrix in the row and only 2 elements in the column of the second matrix. So we're not going to be able to combine these. It's not going to be possible. So in general, the order of the matrices that we're multiplying together must be such that the second number for the first matrix, i.e. the number of elements in the row, and the first number in the second matrix, these must be the same. And then the order of the answer, or the product matrix, will be given by, if that one is an m by something and this is an n by something, something by n, then our answer matrix will be an m by n matrix. These two numbers here, doesn't matter what they are as long as they are equal to each other. So when we're combining matrices, whether it be for addition, subtraction or multiplication, we say that the matrices have to be conformable. Now, for matrices to conform, for addition and subtraction, we saw that this meant they had to be the same size. But for multiplication, we say that the number of columns in the first matrix, i.e. that's equal to the second number, must be equal to the number of rows in the second matrix. And just reminding you then that that means that the second number in the order of the first matrix, that's the number of columns, must be the same as the number of rows of the second matrix. So those two numbers there must be the same. And then if that is m and n, then we end up with a product matrix of order m multiplied by n. So here we have our two examples again. We can see that the first one, we have a 2 by 3 and a 3 by 2 matrix. So they can be multiplied together. They are conformable for multiplication. But the second pair, we have a different number of columns in the first matrix to the number of rows in the second matrix. So they've got different numbers in that pair in the middle. We started this example earlier. If you remember, we said that this was a 2 by 3 matrix, and we're multiplying it by a 3 by 2 matrix, so we're going to end up with a 2 by 2 matrix, and we calculated that the first element there was a 4. Just like you to pause the video and try to calculate the other 3 entries that are in the matrix. Once you've done that, restart and you'll see if we've got the correct values. Well, the other entries that you should have got are 1, 19 and -18. Well, here's a short example of the sort of thing you might be asked to do. To calculate a squared, of course, that means multiplying something by itself. So we need to multiply the matrix 2, 3, 5, -2 by itself 2, 3, 5, -2. It is not the same as just squaring all the elements in numbers. In fact, what I'd like you to check is that when you do that, you end up with the answer 19, 0, 0 and 19. If we're multiplying AB, or trying to find AB, we must write it in that order so that it is 2, 3, 5, negative 2 multiplied by K, 1, C, negative 6. So when you multiply that out, the first element, so to multiplying the first row by the first column, gives you 2K plus 3C, and then the first row by the second column is 2 and then minus 18, which is minus 16. Going on to the second row multiplied by the first column gives 5K minus 2C, and then finally 5 plus 12 is 17. Now, as an extension to that question, you may well be told that AB is given by a particular matrix, and that would allow you to write down some simultaneous equations for K and C. So for example, if we'd been told that this was equal to the matrix, let's say 5, negative 16, 3, 17, then you could see that we have then simultaneous equations. 2K plus 3C is equal to 5, and 5K minus 2C would be equal to 3, and those you could solve simultaneously. Well, that's the end of this video introducing multiplication matrices, and in the next one, section 1.3, we'll be looking at the properties of matrix multiplication.